Hello again. We meet for the third time for today. So, uh, what we are going to discuss now is how do we solve resolutions and additions of forces. There are three methods actually. Either we can use parallelogram, we can also use tip to tail method, and lastly trigonometry. Okay. Suppose you are given this problem. A commercial ship is being towed by two tugboats as shown below and determine the resultant force. You are asked to use a scale of 1 cm representing 1 Newton. So you are given a scale here. So here is the commercial ship being tugged by 3 Newton and 2 Newton. So this here I have one tugboat and here I have the second tugboat. Alright, so the angles from the horizontal is also given in the picture. So how do we solve this problem? So first we look at parallelogram method. Okay, so down there, okay, so here is the ship just now being towed by two tugboat. Okay, so I use different colors for the different forces. Okay, the red and the green color. All right, you see here I have 3 Newton. So our scale just now is 1 centimeter to represent 1 Newton. So here is 3 Newton. So how long must I draw the line? Okay, so from O to A here. Okay, here is our O. Here is our A. Okay, here is our B. So the line OA is 3 Newton and the length of this line, it must be 3 centimeter. Okay, and the angle here, okay, from the horizontal, it is 40 degree. Just like here, it's 40 degree, so here must be 40 degree. Alright, then I draw the green arrow here. Okay, this arrow, the force is 2 Newton. Okay, 2 Newton. So how long must I draw? The length of this line, it must be 2 centimeter. Incline downward at 20 degree. I just follow here. So 20, so it's 20 degree. So now I have this red arrow and this green arrow. So next is just to complete the parallelogram. Okay, segi empat selari. Okay, so I draw this red line, I copy this, I put it here. Manually, okay, I have to draw a line horizontal there, and this angle here, it must be 40 degree as well. 40, here is for 40. Okay, so this line, these red lines here, okay, they must be parallel. And then this one here, I will just draw my horizontal line, okay, as my reference point. And the angle here, it must be 20 degree. Okay, so this line and this line, the green color, the green line here, they are parallel to each other. So now I have a complete parallelogram. Segi empat yang selari. So just draw a line diagonally from my O here, my origin here. I draw it diagonally towards the other end until here. So next what you do is you measure the length of this line. Okay, you measure the length of this line. Let me check first because I don't measure it. Okay, if you measure this and if you do it correctly, the length of this line, okay, the length is about 4.4 centimeter. Okay, it's more or less 4.4 centimeter. Hence, okay, the resultant force F is 4.4 Newton. Why? Because the scale we are using just now is 1 centimeter representing 1 Newton. Okay, so that is the first method. Second method, what we call as tip to tail method. Okay, so basically the same thing, it's only half of the parallelogram. Okay, so why do we call this tip to tail? Because you have to draw the arrow from tip of the other one and to the tail. Okay, now so we refer to our questions. I have my commercial ship, okay, being towed by two tugboats, one pulling it at 3 Newton and the other one pulling it at 2 Newton, and it makes an angle of 40 degree and 20 degree respectively. Okay, so 3 Newton, the scale we are using is 1 centimeter representing 1 Newton. So the length of this line, if I am to draw, it must be 3 centimeter. So here the length here must be 3 centimeter. It represents 3 Newton. Okay, so I draw the red line first. Okay, and then I draw my reference line, a horizontal reference line. Okay, because the angle here is 20, so I measure using my protractor. It must be 20 degree here. Okay, then I draw this line, and the length of this line, since it is 2 Newton, so the length here must be 2 centimeter, representing 3 Newton. So we are just following the diagram given to us. Okay, here is 40 degrees, so the line here, the red line, it must be inclined at 40 degree upward. And this green line, okay, it's 20 degree given in the diagram, so the line must be 20 degree downward with respect to the horizontal. Okay, so here is the tip of this red line. Okay, this point here is the tip of my red line, and it is the tail of my green line, hence the name tip to tail method. Okay, so we continue. So we start from this point, we end here. So just connect these two dots, okay, to form this black line. So this is my resultant force. It's going from O to B. So it's going upward. So you can use your protractor to measure what's the angle here. Okay, it's 16.5 degree, more or less. So, and then you measure the length of this line. Okay, since we have the same problem as just now, so the length of this line is about 4.4 centimeter. Therefore, the resultant force is 4.4. Or maybe I just do it mathematically. 4.4 centimeter, and we are using the scale of 1 centimeter to represent 1 Newton. So centimeter can be cancelled. So we end up with 4.4 Newton. Okay, so to measure the length of the line, then you have to use your ruler. That's why I reminded you that you must always have your ruler with you and also your protractor. Okay, now so far we have discussed two methods, parallelogram, and then we have also discussed tip to tail method. The third method, which I shall call the trigonometry method. Okay, you've learned this in your math class. So I have a ship here being towed by 3 Newton at 40 degree from the horizontal, and I have a 2 Newton force, okay, exerted by another tugboat making 20 degree downward from the horizontal. Okay, so I'm to analyze this separately. Okay, so I redraw my my red arrow. Okay, here's my red arrow. It making 40 degree from the horizontal is going upward. Okay, so my red arrow is going upward. So I just follow. I going to the right and then I go up. Hence, you can see that my arrow here is going to the right and then here it's going up. Okay, do you follow me? Okay, so Let's call this as my f1. So I will name this as my f sub 1 x. Here is f sub 1 y. Okay, why I use x and y? Well, simple. X to represent the horizontal axis, y to represent the vertical axis. Okay, now look at the green arrow here. Okay, the green arrow, it make a 20-degree, okay, downward from the horizontal. So I start from here, I end here. Okay, so I'm going downward, I'm going to the right, and then I go down. That's why you can see that my arrow is going to the right first, and then I will go down. So let's name this as f2. Okay, so this one here I will name it as f sub 2x, and this one here we name it as f sub 2y. Okay, so we are going to resolve the f1 and f2 forces into the vertical and horizontal component. Okay, let's look at this one first. Okay, if I take my sin theta equal to opposite, correct, divided by our hypotenuse. Okay, so here I will write f sub 1y divided by f1. So f sub 1y, I will get f1 sin 40. Just plug in the value, you will get 1.9284 Newton. Okay, so if f sub 1y is sin 40, we use sin 40. So down here, automatically, we are going to shift to use our cos of 40-degree. Okay, so f sub 1x equals to 3 Newton multiplied by cos 40, you will get 2.2981 Newton. Okay, that is for the first diagram here. Now, let's move on to the second diagram. Okay, I have my angle here. Okay, I put here sin 20. So sin 20, sine would be opposite divided by hypotenuse. Okay, so here you can see I write my equation as f sub 2y divided by f2. So f sub 2y will equal to f2 multiplied by sin of 20. So f2 is 2 newtons multiplied by sine 20-degree, you will get 0.6840 Newton. Since y I'm using sin, so definitely x I am going to use my cos. So f sub 2x equal to 2 Newton multiplied by cos 20, you will get 1.8794 Newton. You see, we have resolved our forces into our vertical axis, okay, y, the vertical component, and also the horizontal component, our x-axis here. Okay, so next what we do is we have to sum up. Okay, we sum the forces in the vertical and also in the horizontal respectively. So the total force acting in the x-axis, f sub x, that will be f1x plus f2x. Okay, so f1x we have 2.2981 newtons, and then plus f2x that will be 1.8794 newtons. So we will end up with 4.1775 newtons. So we do the same thing for our vertical component, that is our fy. So my fy here is f1y plus f2y. Okay, f1y, okay, is 1.9284 Newton plus f2y negative 0.6840 Newton. Oops, why negative here? Where does this come from? Okay, so let's go up to our diagram. Okay, f2y, it is going down. So our sign symbol, remember? Okay, so that's why our f2y here, I have to put a negative sign because it is going down. Here is positive because it is going up. Alright, so we do our final calculation. You will end up with 1.2444 Newton. Simple. Okay, so this is the net force acting in the horizontal direction. Okay, and F sub y is the net force acting in the vertical direction. Remember that you must conform, okay, conform with the sign convention. Okay, going to the right is positive, going to the left is negative, going up is positive, going down is negative. Okay, so the final step, right? So I have my f sub x is 4.1775. So here is my f sub x, and then I have my f sub y 1.244 Newton. So I'm going to draw my resultant force. Okay. So I start here, I end here. So this is my resultant force. Okay. So Pythagorean theorem. Correct? So f square equal to fx square plus fy square. So you do your calculation, you will get your F equals to 4.3589 Newton. Okay, that's how you solve the problem. Before I leave this page, I would like to put a simple note here. Here is a resultant force. Okay, resultant force. Daya paduan. Okay, if I draw my arrow going down, okay, if I have something like this, okay, I have arrow going up, going to the right, and then it going to going up, and then it goes down like this, and this here is a right triangle. So what does this mean? It simply means that the system is in equilibrium. Okay, it means that my net force is 0. But here I don't see my arrow. Okay, it's going in one direction, one cycle. Instead I start from here, I end here. My arrow is going up. So these two are not the same. Alright, so that's all about it. So I'll see you again next time. Bye bye.